Hi, today we will be doing a presentation of Lewis dot structures. First, we will be starting with carbon dioxide, CO2. First, we will be determining the valence electrons for CO2. So carbon has 4 valence electrons, and oxygen has 6 valence electrons each. And I add them together, and 4 plus 2 into 6 is equals to 16 valence electrons. Now I will be drawing a Lewis dot structure for CO2, carbon dioxide. I put C in the central because C has a very low electronegativity. And I put oxygen atoms here, one in here and one in here. I draw the two lone pairs on each side of with carbon and oxygen atoms. One in the two here, two on this side, and other two on this side. And I put 4 lone pair, 4 and 2 dots of 4 dots of oxygen atoms on here on the oxygen side. 1 2 3 4 here, and 1 2 3 4. Now will be here is a model that I made for carbon dioxide, CO2. Here it is. The carbon in here is the carbon, so the central atom is carbon is the central atom, so the central atom carbon is green here, and the other two oxygen atom is pink in color. I made this with I made the model with toothpick stick and 3 marshmallows of different colors. And the bond angle for the bond and the ADG for the CO2 is linear, and the shape is also linear, and the bond angle between CO2 is 180 degrees Celsius, 180 degree, 180 degree. And now I will be determining the polarity of the structure. The polarity from carbon and CO is a polar covalent bonds. And it is and carbon has a positive delta sign because it's a low electronegative atom. And CO and oxygen atoms are I put negative delta signs because it is a more electronegative atoms. And under formal charges for CO2, O is 0, C is 0, and O is also 0. And hybridization of carbon atom is sp, and the overall polarity of carbon atoms CO2 is non-polar because CO bonds are polar, and all 4 polar bonds pulls out equally and cancels out, making it overall a non-polar bond. And the hybridization of CO2 is sp, and the hybridization of C atom is sp. Now I will be doing, and overall shape of CO2 is and the shape EDG for CO2 is linear, and the shape is also linear, and the bond angle between CO2 atoms is 180 degrees Celsius between the adjacent atoms. Now I will be doing for CHO2 electron. CHO2 CH2O CHO2O. Carbon has 4 valence electrons. Hydrogen has 1 valence electrons each, and oxygen has 6 valence electrons. So the total valence electrons for CH2O is 12, and I will be drawing the Lewis structure for CH2O. Here I will be drawing here, and notice all of these electrons has an octet. Sorry, this is not right. I will be drawing a CH2 here. I put four dots of atoms here over our oxygen, O2 atoms. Now I will also show you the model that I made for CH2O. Here is the model for CH2O. I like the previous model. I also made it with marshmallow and toothpick sticks. The marshmallows I color are marshmallows. I put 2 hydrogen atoms. For 2 hydrogen atoms I put 2 hydrogen atoms I put pink marshmallows, and 1 oxygen atom I also put pink marshmallow for the oxygen atom, and for the central atom I put is green in. And the bond angle between and the EDG for CH2O is triangular planar, and the shape is also triangular planar. And the bond angle between the adjacent atom is 120 degrees Celsius. Now we'll be determining the polarity. CaO and O bond is polar, and CHO bond is also polar covalent, and CH bond are polar covalents, and CO bonds are polar covalent. And since C is the least electronegativity, negativity, so I give the delta sign for C is positive delta notation, and H is also more electronegativity than C atom. I give it a negative delta sign, and oxygen atom is also more electronegative than the C atom. So I give it a negative delta sign for our oxygen. And I put C in the central because it is the least electronegative atom, so I put C in the central. And hybridization of the C atom is sp square, and overall polarity of the bond is polar, because the polar bonds for this atom, polar bonds between the polarity between the bonds doesn't pull out equally and doesn't cancels out, so making the entire structure polar, overall molecule polar. And the formal charge for this for the entire structure, C is O, H is O, 0, I mean C is 0 and H is 0, H is also 0, and oxygen is also 0. So the overall formal charge of C is 0, oxygen O is 0, H is also 0, and hydrogen H is also 0 as well. Now we will be doing next is ASF3 structure. And the valence S has AS has 5 valence electrons, F has 7 valence electrons each. So the total valence electrons is 26 valence electrons. I put S in the middle because S is also has a low electronegativity, and fluorine atoms has more electronegativity each. I give single bonds to the fluorine atoms. Now I will be showing you that model that I also made for ASF3. For the model, the EDG of ASF3 is tetrahedral, and the shape for ASF3 is trigonal pyramidal, and the bond angles between the ASF3 is 96.2 degree is between the adjacent atoms. I made this model using colored marshmallows and toothpick sticks, and I put the F3 atoms. I put the AS atoms on the central. The green marshmallow is the AS atom, and the pink. The rest of the pink, other 3 pink marshmallows are the F atoms. The formal charge of F is 0. And AS is also 0. And the AS and AF are polar covalent bonds. So the polarity arrows is this. AS is since AS has a low electronegativity, I will give I put the delta notation of AS a delta positive, and the delta notation for fluorine atom is delta negative. So the hybridization of ASF3 central atom is sp cube. Hybridization of the central atom of ASF3 is sp cube, and the overall polarity of each ASF3 structure, and the overall polarity of ASF3 structure is polar, because the polarity arrows don't cancels out, are not equal, and they don't cancels out each other, making the overall structure polar. That's it. And and the shape for ASF3 is pyramidal, trigonal pyramidal, and EGG is tetrahedral. Now next I will be showing you SeCl4. First I will be writing the valence electrons for SeCl4. Sc has 5 valence electrons, and chlorine has 7 valence electrons each, making the total valence electron is 34. Now we will be drawing you the structure of SCCl4. I put Sc in middle in the central all position because Sc has a low electronegativity, and all the Cl4 atoms, all the atoms in this compound are octet and follow the octet rule. If one Cl atom here, one Cl atom here, and one Cl atom here, and one Cl atom here. I give lone pairs. Now I will be showing you a model that I made for SCCl4. The model that I made for SCCl4 is also toothpick sticks and marshmallows, colored marshmallows. I put the central SCCl3 on the I put the marshmallow for SC on the central on the top, which is the green color marshmallow, and for the rest of the pink marshmallows in the lower bottom are the Cl atoms, which is pink in color. And the shape for SCCl4 is trigonal bipyramidal, EDG for SeCl4 is Cl4 is trigonal bipyramidal, and the shape for SCCl4 is seesaw, and the bond angle between the adjacent seesaw, and the bond angle between the adjacent atoms is less than 90 degree, and greater than 90 degree but less than 120 degree is. Now I will be determining the polar charge, and formal charge. The formal charge of Sc is 0, Cl is also 0, Cl is also zeros, and 0 and 0. And the polarity is, I also determined the polarity. SCl are polar covalent bonds. Polar covalent bonds. And so Sc has a low electronegativity, so I give the Sca for positive delta notation and Cl negative delta notations. So the overall polarity of this structure is polar because the polarity arrows don't cancel out each other, are not equal, and don't cancels out each other, doesn't pull out equally and don't cancels out each other, making the overall structure is polar. And hybridization of the central atom Sc is sp3d, sp cube d. Sp cube d is the hybridization of Sc central atom. Moving on to the last molecule of the day, we have ZeF4. Ze has 8 valence electrons, and while fluorine atoms has 7 valence electrons, and making the total valence electron is 36. So there are 36 valence electrons. Now we'll be drawing the valence electron for Lewis-Strauss structure for ZeF4. I put Ze in the central, xenon in the central, because xenon has a low electronegativity. So I put it in the central position, while I put the rest of the fluorine atoms and in other places, because they have more electronegativity than the xenon atom. So I will be showing also a model that I made with 3D model of ZeF4. So the overall structure. So the structure of the ZeF4 is ADG. ZeF4 is octahedral, and the shape of xenon ZeF4 is square planar, and square planar. I made this model using it toothpick stick and colored marshmallows. The fluorine atoms, the pink marshmallows are for the fluorine atoms. I put the marshmallow for the xenon Ze atom in the central, and the color for the Ze atom is green in color. So the EDG for ZeF4 is octahedral, and the shape for our ZeF4 is square planar, and the bond angle between the adjacent atoms is 90 degrees Celsius in 90 degree each, and 90 degree each, and the hybridization of xenon atom is sp cube d square. Sp cube d square is the hybridization for the central atom Ze. Now we will be determining the polarity of this structure. ZeF is the overall polar covalent bonds. So I'm drawing these arrows, polarity arrows. And the formal charge is 0, 0, 0 for xenon atom and 0 for fluorine atoms. And since xenon is the has a low electronegativity, so I give it a positive delta sign, and fluorine has more electronegativity than the xenon atom. I give it as a negative delta sign. So the overall structure for ZeF4 atom is non-polar, because the polarity atoms, due to the fact polarity arrows all pulls out equally and cancels out, making the overall structure overall structure non-polar, making the overall structure non-polar. And that's it.